Okay, today what we're going to do is we're going to keep doing rotations, except we're going to rotate around points that are not the origin. Like, for example, in this problem, we're going to rotate around point K. And I'm not going to lie, it's a little bit harder than what we've been doing, but that's all right, we can handle it. So, here, we're going to start with point C. There's a couple different ways to do this. I'll show you both. So from point C here, we figure out how do you get to K? Well, you get to K, you go 2 units to the right. So then, since it's a 90-degree rotation, which we're going to stick mostly with that today, 90-degree rotation, what you want to do is you want to turn 90 degrees counterclockwise once you hit C. Right there, if you go 2 units down, that makes point C prime right there. Okay, that's point C prime. So now we're going to look at the other points. So we're going to look at, point B. So point B, I'll do that in blue for B. You get to point K, that's like one diagonal box that way. And when you turn 90 degrees, you're going to end up going one diagonal box that way. See how it creates a 90-degree angle? So right there, that is going to be point B prime. And actually, just to save a little energy here, let's erase all of those other lines in the way. Okay, and then finally what we're going to do, we're going to go from point A. So point A, to get down to K, if you look at it, you're going 2 to the right and down 3. Like, you see that? You're going 2 right and then down 3. What we want to do, we want to go perpendicular to that. So we want to go down 2 and over 3, like that. So point A is going to be right, down 2, over 3. Point A prime is going to be right there, giving us the triangle A prime, B prime, C prime, right here. Now, one thing that's super helpful with this, you notice how A prime and C prime are on a straight line, just like A and C were on a straight line. And like, B and C are one over, one up, that sort of thing. They're one away from each other in both of those. That's going to be really helpful because, again, this is a rigid motion, so the shapes have to be congruent. Another way to do it over here is if you draw the axes in like this, like you make pretend axes right there, you can trace this on patty paper, you can trace this on patty paper, and then rotate it 90 degrees. And then you'll see that these end up right here, and you can just read the points off of that. There's an algebraic way too, you can look it up if you want. Okay, so with this, what we're going to do, we're going to go from A to M. See, it's like up 1, over 2. And then we're going to turn 90 degrees because we're going 90 degrees counterclockwise. And one thing that kind of helps is like you realize that it's got to go like over there-ish or so. It's going to go like here, this kind of general region over there. So in order to do that, we need to go perpendicular to this. So we need to go down 2 over 1. So you see how like this creates a 90-degree angle right there? That's A prime right here. Cool. So now let's look at the other ones here. Get rid of that. Okay, so if we go with B next, to get to B, see it's up 4 over 2. So it's like a slope of 2. So what we want now is a slope of negative 1/2. We go down 2 and then over 4. B is right here, placing it 3 units away from point A prime as well. If you count like right here, 1, 2, 3, that should also be 1, 2, 3. And hopefully you can kind of see that if it goes 3 units here, we just turn 3 more units up, and C prime ends up right there. So using the fact that a rotation is a rigid motion can really help with these situations because the shape's going to look exactly the same, except it'll just be rotated slightly around this point.